So finally, let's get into a couple of the consequences of the mean value theorem. The first consequence of the mean value theorem that we can take out of this is that if you have a function and that derivative of that function is identically equal to 0 on a given interval I, then it will be true that f of x is equal to some constant value on that same interval. Now, to give you an idea of how this works, I would like to consider the following function. F of x is equal to the sine of x plus the cosine of x, quantity squared, plus the sine of x minus the cosine of x, also quantity squared. What I intend to show is that this function is constant on the set of all real numbers, the domain of this function. So show f is constant on the interval from negative infinity to positive infinity, and determine that constant. So with that in mind, let's go ahead and take a derivative. We will get to practice a couple different things. Because we have some powers in here, we'll see the power rule. Because we have compositions, we'll see some chain rule in here. All in all, it should work out great. So first, applying the power rule to the first set of parentheses, that'll be 2 times that same set of parentheses raised to the first power times the derivative of what's on the inside of the parentheses. In this case, that would be the cosine of x minus the sine of x. Then we'll move on down to the next line for the second set of parentheses over here. Again, we'll start with the power rule and say 2 times this thing raised to the first power, and then multiply by the derivative of what's on the inside. Derivative of sine of x, that will be cosine of x, and derivative of negative cosine of x will be plus sine of x. Now, the thing that I'd like to observe between these two things is that they both have a 2 in common, and they both have a sine of x plus cosine of x in common. So what I'm going to do is go ahead and factor those out. When you factor those out of the first big term up here, you're left with just this set of parentheses. That's a cosine of x minus the sine of x. And when you factor it out of the second set of parentheses, you get just this set of parentheses left over. So that'll be plus sine of x minus cosine of x. Now, if you take a look inside this set of parentheses, there are a lot of like terms that can be combined. I see a cosine of x minus cosine of x. Those cancel, and a sine of x minus sine of x, those will cancel as well. So what's inside this set of parentheses is equal to 0. Because we're multiplying by this, we can conclude that the whole thing is equal to 0. Now, with that in mind, according to the consequence of the mean value theorem, we have just shown that f is a constant function. We still need to show what constant it's equal to. So f of x is equal to some constant. To figure out what constant, we can plug in any value of x, because we proved that this was true for all real numbers, as that is the domain of the function. Now, when it comes to trig functions, you can pick any of our familiar angles, such as, I don't know, pi over 4, pi over 3, pi over 6, pi over 2, or you could go with my personal favorite, 0. That way we can figure out what this constant is equal to. So that'll be sine of 0 plus cosine of 0 squared plus sine of 0 minus cosine of 0 quantity squared. Sine of 0 is equal to 0. Cosine of 0 is equal to 1. So we're looking at 1 squared plus negative 1 squared. Our constant that this function is equal to is 2. Now, there are, of course, other trigonometric ways that we could have shown that this was equal to 2, but I think this is a pretty fun way to integrate some calculus into the process.